Our transportation system is designed for humans, but over 90% of crashes on the road today are due to some type of human error. Clearly, we have a very human problem that needs to be solved.
Complex research problems require putting together the right teams.
Our research here at NADS is focused on the intersection of the driver, the vehicle, and the roads.
We have been intimately involved with simulation research, and we cover a broad range of simulation expertise. The key research areas at NADS include understanding how driver behavior and performance can be used to look at driver state detection. We're looking at how drivers interact with connected vehicles and automated vehicles, vehicles of the future. And then we're also looking at how to evaluate new and advanced vehicle systems.
NADS has been at the forefront of understanding how signals from the vehicle and the driver can be combined to detect what the driver's state is. We've developed a series of models that use this sensor data that comes from either the driver or the vehicle to identify whether or not a driver is impaired from drowsiness, distraction, or alcohol.
Mitigation is really the link between detecting driver state, detecting impairment, and the driver. So once we detect that a driver's impaired, what do we do about it? So we're interested in examining how drivers process information in a fairly basic sense. So we need to understand how drivers' attention works, what sorts of limitations we have in terms of cognition. That includes a range of things, including what sorts of activities might distract the driver, what sorts of messages we can present to the driver, and the driver have those be effective. And really the goal is to understand how those limitations translate into driver behavior.
Mitigation can involve displaying icons, or playing sounds, or vibrating the seat or the steering wheel. How you warn the driver is best determined by what state they're in. Automated vehicles are poised to change the face of transportation and mobility. And this revolution is going to happen at a relatively fast pace. But before we have a world that consists only of automated vehicles, there are several complex issues that need to be explored and addressed. That's where places like NADS are really poised and positioned to do that type of research.
One of the biggest research topics in the area of automated vehicles is the transfer of control. How does the car give control to the person, and how does the person give control to the car? One of the things that we have here at NADS is a very large, high-fidelity motion base. So in our study of automated vehicles, the driver will often be looking away from the road, being engaged with something completely different. And as researchers, we want to study that behavior. So we need motion for that. Automated vehicles have a lot of potential benefits. Number one is safety. Over 90% of crashes today are caused by human error, and automated vehicles have the potential to eliminate those.
Simulation spans psychology, engineering, computer science, public health, public policy, law, medicine, any field that has the potential to impact safety. We have collaborators across all those departments within our consortium.
When you have people from different disciplines, from different experiences working together, you get a much more holistic approach to solving a problem.
We collaborate nationally using our mini-sim network. One example is a data collection effort that included 5 sites across the U.S. to collect a national population sample. The Safer Sim Consortium of universities is moving simulation technology forward, helping it address more safety issues both on national and state levels. We really are trying to look at new ways that simulation can look at the emerging issues in transportation safety.